Hello, Daryl here. The channel is Programming in Any Language. The supporting website is programminginanylanguage.com or black-duck.com. They both take you to the same place. And it's a place where you'll find the videos and PDFs of the code. The video is encapsulation. Encapsulation is also known as data hiding. We've been doing that in the structure section and the class section. However, when you open up a book on programming and jump to the OOP or Object-Oriented Program section, you usually find encapsulation there along with inheritance, abstraction, and polymorphism. Call it the big word section. Sometimes I wonder if the powers that be use the big words just to impress the rest of us. Be that as it may, encapsulation, as I said before, is simply data hiding. Some of what you will see in this video you have seen before in the classes section, especially the intro lesson and the properties lesson. But this video concentrates on containing data within a single unit and shielding it from the outside world. The video is more of a why than a how. I look at object-oriented programming as more of a necessity when working with teams of other programmers. You create your class and let others use it. Meanwhile, you have the peace of mind that as others use the class, the data will be protected through the rules you set up when developing your class. If you're a lone programmer, there is no one making you use OOP. However, it is a good practice to follow. Let's take a look at the video and understand what we really mean about encapsulation and data hiding. In the classes section of the website, encapsulation was demonstrated regularly, but the name encapsulation was not mentioned. The video directly looks at the concept of encapsulation and puts it in place as a form of data hiding. So we're calling this video here Encapsulation. Encapsulation hides the internal state and functionality of an object, only allows access through a public set of functions. Basically, encapsulation is data hiding. I like to think of it as a cave, and you're going to see why I use that analogy in a little bit, because in a cave, there's one way in, and there's only one way out, normally. And that's what we're going to see here. Encapsulation hides the internal state of functionality for an object and only allows access through a public set of functions. We have something called the name property right here, where str name equals value and return str name. There's basically two ways of getting at this thing. You can read it and you can create it. And so that name property then is something that we have in here. And there's only doorways to get in. Let's look at this in a little larger section here. The process of binding or grouping the state and behavior together in a single unit, class, interface, struct, etc., is called encapsulation. Encapsulation ensures the state and behavior of a unit, class, interface, struct, etc., cannot be accessed from other units. Class, interface, struct again. Here's that cave. We'll call this one class pet. There's a name property, as I mentioned before, in there, the str name value and return str name. Basically, what's happening here is we have a backing field up on top here, and then we have the str name, Ranger Bob, which is being applied to it. Now, we can change this, but we can only do it through one way. We can set it through a set accessor, a setter. And we can return it only through a get accessor, who's going to get it for us. And then we have the current name, which is a void method, a method of some kind that can bring it to us. And you're going to see that shortly. The properties look like this. If you actually look at it, there's that backing field, str name here, and here's that Ranger Bob being set here in the str name. And here's that the name with the property, which is showing you the getter and the setter. Returns str name equals value. So if value comes in, we can set it. It'll make the change up here. Or we can return it and bring it to us. We can also grab it through methods. And this message box I show, str name is going to grab str name and bring it down if you call the current name method that's sitting inside this property. The thing is, they're all gathered together here as one unit. When a value is assigned to the name property, it is stored in the backing field. The private backing field is a variable that stores a value assigned to the property which the backing field is associated with. It is declared to be private to protect it from accidental corruption. If a backing field is public, it can then be accessible directly by code outside the class without the need for accessors. And it's pointless then to actually create the class if you're going to allow everything to get added. When an instance of the class is created, the constructor assigns a value if one is coded. When the class is instantiated, the fields will be first initialized to the values listed in the declaration statement. Then the constructor will execute assigning its value to the fields. The beginning of the property declaration specifies access public, data type string, and the name of the property. Each property in the class has a name as well as an access specifier and a data type. This is specified in the beginning of the property declaration. There can be multiple properties in a class. We just have one here, but you can certainly make more than one. The get accessor, a method that returns a property's value. Each property has a get accessor which is used to return the property's value. The get accessor is executed anytime the property is read. The set accessor, a method that sets the property to a value. The purpose of the set accessor is to set the property to a value. The value parameter is automatically created by the compiler, and its data type is the same as that of the property. A read-only property will not have a set accessor, as the property value will never be changed. So how do you make it read-only? You get rid of the set. You don't have one of these. A typical method coded with the class and accessible by the name looks like this. Any number of methods can be written within the class. Methods internal to the class have full access to the properties. So these guys can get at this stuff up here. Once again, the cave. The properties are protected. There's only one way in, the set. The get is going to get it out. That's it. And of course, you can have void, you can have different methods in here that will be able to get access to the string name here and bring it out as well. But the thing is, it's a doorway. There's only one way in. Every class, interface, struct, enum, etc. that we create is an example of encapsulation. On the right is a class called debit card. We will use it to help us understand encapsulation. Our debit card field right here. We're going to take a look at how this actually works. What we've got here is we got a field, a constructor, a balance property, a deposit, and a withdrawal two methods here. We don't have any set, as you can see. Let's take a look. The debit card class is an example of encapsulation. The variable DEC balance and methods DEC internal balance, deposit, and withdraw are bound in a single unit. All this stuff is all a single unit. It's all protected. The value of DEC balance is hidden. It can only be retrieved via the getter. The value of DEC balance is hidden. It can only be changed by the method deposit and withdraw. These two methods can make the change to it by bringing in an amount and applying it to the DEC balance here. Plus equals, minus equals. The encapsulation binds the implementation details of the debit card class and hides it from other classes. To access the details, other classes need to create the object of the debit card class to access its data and its behaviors. Here's a case where we're actually creating that instance and we're assigning $1,000 to the class. My bank card, private debit card, new debit card. $1,000 is going into that thing, sitting right here. And form load, and then it's taking the LBO balance, and mycard.internal balance is using a method to actually bring that amount that's stored in the class and paste it on the form here so we can actually see it. The deposit method has a DEC amount field, and we're looking at an amount coming in from the text box here, and it's being checked, it's been parsed to see if it actually is a valid data amount. My bank card.deposit is being called. So the deposit method is taking that amount and applying it to the DEC balance. An LBO balance, my card is taking it and displaying it again once it gets up into here. You'll see that in a second here as you can see it bouncing up. The internal balance is brought in, and then my bank card is showing the results of what we actually have here. So that's how you can deposit an amount in there without ever touching this field. You're applying it. Withdrawal works the same way. We have an event here, a DEC amount coming in from the text box. It's being checked, if statement, my card.withdraw amount. So DEC amount is going into the class where it's going to be applied, and DEC balance is going to subtract it from the DEC balance. And then we're going to apply it. We apply it by simply taking my card DEC internal balance and putting out to the label so we can actually see it there. And up it goes, and you can see that happening. Data hiding or information hiding is a process in which we hide internal data from the outside world. The purpose of data hiding is to protect the data from misuse by the outside world. Data hiding is also known as data encapsulation. The process of defining a class by hiding its internal data members from outside the class and accessing those internal data members only through publicly exposed methods, setters and getter methods, or properties with proper validation is called encapsulation. How do you implement it? Data encapsulation is implemented by declaring the variables as private to restrict their direct access from an outside class, and then by defining one pair of public setters and getter methods or properties to access private variables from outside the class. The main reason for using data hiding is security. As we use private access specifiers with our variables, we can store critical information in such variables, which will only be visible to the class. No one else can access them directly. We can also apply validation in setter and getter methods whenever needed. This increases security so that no one can set any illegal data for misuse. Let's take a look at an example. I've got here the encapsulation demo form set up here with that balance field in there. And we'll actually look at the properties on here. You can see that this particular property is called LBL balance. This is a text box right here called TXT deposit and TXT withdraw. We have a button called BTN deposit and a button called BTN withdraw, and an exit button which will get us out of the form and get us out of there completely. So how do we actually put this thing together? Well, the first thing we do is we create the debit card class. We'll call this guy debit card. That sets our code, and we can now pop in our field. There's our DEC balance. Now we can set up our starting balance by putting this debit card piece in here, starting balance, allowing us to accept the starting balance as we actually create this thing. So this DEC balance will be equal to DEC starting balance. So we can actually put our $1,000 in this thing if we want. If we leave it blank, it'll be zero out there, and we'll simply have to add deposits or withdraw amounts from it to still make it work. But we're putting in the starting balance. It's like reading a database and finding a customer and saying, oh, he's already got $1,000 in his bank account. We'll put it in there, and then we'll apply any changes he's going to make. Next thing we do is put our property in place. The DEC terminal balance. We have a getter, which is a return DEC balance. So we can get it whenever we need to get that balance. We can get it from here. Do we have a set? We don't have a setter in here. But what we do have is methods that are going to do this for us. We have a deposit method and a withdraw method. And they look like this. DEC balance plus equals amount, DEC balance minus equals amount. So we're going to be able to take data from the text box in our form and add it to the DEC balance, or take it and subtract it from the DEC based on which method we actually call here. Again, data hiding, everything's hidden. We can't get at this guy without going through these doors, basically, to make it all work. First thing we'll do is do our exit button. Get that out of the way since it's simple. And we're going to go to our form load and apply that. That looks something like this. I'm going to move this closed form out here a little further. So my bank card is going to be equal to the DEC starting balance right here. We have an error right here because we haven't basically created this thing. There's nowhere else on here, as you can see. And we'll do that up on top. So as soon as we come into this, we'll leave that right in here. Debit card, my bank card equals new debit card with $1,000 being placed into it right here. Now, this should work. We can't do any withdrawals or deposits yet, but this is enough to make this thing work. If we check this thing out, our form's going to come up. There's our $1,000 showing in here. This doesn't work yet. We haven't encoded it. But we're actually showing a starting balance of $1,000 in our class. It's hidden. Can't get at it except through applying it through our deposit and withdrawal methods, which we'll now create. This should work as well. So we're going to go to our form, and we're going to look at our deposit button first. For our deposit button, we're going to set up a decimal amount DEC amount. So we have a variable that can hold data when we bring it in. We're then going to check it because we need to find out if the amount is valid. Somebody could have typed in ABC in our text box and it's going to fail. So we'd have to actually check that and say invalid amount. But if we do have a correct amount here, DEC amount coming in, and we check it, we're going to go ahead and call the deposit. Put that DEC amount in our deposit method and send it to our class, which is then simply added to our balance. We're then going to go ahead and pull that DEC internal balance out and show it on our form. And we'll clear the text box then so that the user can do something else as we go in. We're also going to go ahead and do the same thing with withdraw. It's almost the same code here. We're using DEC amount again, private to this particular button. Again, we do a check to see if it's valid or not. And here we do our bank card withdraw. We call the withdraw procedure from the class. And then we again go ahead and display our account. So basically everything's the same except we're calling a different method. So this is all done. That's all we need to do. We can actually go ahead and save this thing now and start it out and see what happens. A form comes up with $1,000 in it. We want to add some money to it. We can certainly add $500 in here by putting 500 in there and hitting deposit key. And up comes $1,500. We can withdraw $99 and it can subtract it from the amount. We can do another one if we want. Subtract another $99 and it goes down even further. Come in and put another $300 in, deposit, and up it goes. So we're using these particular fields, these text boxes, to apply it to the class balance without touching anything except going through the procedures or the methods that are in the class itself. This is basically data hiding, data encapsulation in a nutshell. Some of this look familiar? Probably. Hopefully it clears up any issues you might have had since we worked on classes. Next big word to cover is polymorphism. We'll take that one on and redefine it in plain English. Thanks for watching. Visit the website when you get a chance, and please subscribe to the channel. There's more stuff coming every week. We'll see you in the next video. Take care.